Hello and welcome to Surrey Raw County's first virtual camp. Hope you're finding lots of interesting activities and ideas to take back with you to your groups. This is a very quick guide to astronomy to help you with the astronomy badge for the various sections. So we start off with an image of the solar system with the sun on the left and going off to the right with the little dwarf planets Pluto and Eris. There are other objects further off out to the right, such as the asteroid belt, the Oort cloud, things like that, which I haven't actually included in today's little talk. The planets can be divided into two groups. So we have Mercury, Venus, Earth and Mars are classed as the rocky planets. And then we have Jupiter, Saturn, Uranus and Neptune are the gas giants. And as you can see from the sizing on the image there, Jupiter is by far the largest of the planets, but more of that in a moment. So this is a little image I thought I'd include to show you the various planets and their orbits out round the sun down in the bottom left there. The sun, diameter 109 times the Earth and sitting 93 million miles away from us. Very active. If you've ever seen any videos of the surface, you'll see it's in constant movement. The white spots are in fact sunspots and areas of activity, and you'll notice around the edge the solar flares that are coming off from the surface of the sun. The sun is a subject on its own, really. There's so much information about it, which I haven't covered in this, but a quick internet search will bring up a lot more information. One website in particular I found is the NASA website, which has an enormous amount of information about just about everything to do with the sun, planets, solar system, you name it, it's there. This is early photographs of Mercury, as you can see, a little bit blurry, not a lot of information or detail there. Mercury has a diameter of 3,031 miles and sits at 36 million miles away from the sun. However, with the new space probes and things being sent up all the time, this is a clearer image and it shows the cratering on the surface of Mercury and just how barren. It looks very much like our moon to a certain degree, with all the various craters that you can see there. Next we move on to Venus, cloud covered, not a lot of information that you can make out from this sort of image as to what the surface is like. The space probes have to get down below the cloud cover to see anything at the surface, and the pressures and temperatures are very high and hot. So space probes haven't lasted that long on the surface of Venus. It has a diameter of 7,520 miles and it sits at 67 million miles from the sun. Hopefully one day they'll be able to give us better images of the actual surface, but I feel that's some way off for now. Next we come on to Earth, good old blue marble, 7,962 miles in diameter, and we're sitting 93 million miles away from the sun. Our moon, which is orbiting us, it's not the only moon in the solar system. I'll be coming on to those a bit later on. Planet Mars, one of the most favourite and fabled planets of all times. In early years when it was first discovered, the quality of the telescopes obviously wasn't as good, and it looked as though there were lines on the planet, and due to a mistranslation from I think it was the Italian canale, meaning lines, it got translated into canals, and in Victorian times it was thought to be inhabited and had canals of water flowing all over it, which we obviously know now not to be true, although there is evidence that there was water on Mars at some time. The image you're seeing there is a canyon. It's about 100 times bigger and longer than the American Grand Canyon. And Mars has proved very interesting, with lots of interesting features to it, such as Olympus Mons, which is the biggest volcano within the solar system that we know of today. Mars is 4,217 miles in diameter, and it sits at 142 million miles away from the sun. Jupiter, we're now onto the gas giants, and the diameter leaps up to 88,846 miles, which you can see is quite a big leap from the previous planets. And it sits at 484 million miles from the sun. So it's a big jump from Mars, which was 142 million miles. Though it's cloud covered, it's got lots of interesting features to it. The image there shows the big red spot that circulates around the planet in that band of clouds there, and you can see the various swirls and features in the cloud caused by its rotation. This is an image showing the Earth size in comparison. There's about 11 Earth diameters will fit across the face of Jupiter. So it is one very big planet. Saturn, our ringed planet. The rings are made up of, it's thought to be, icy particles and form distinct bands. Again, there are some stunning images on the internet from the Cassini space probe that orbited around the planet for quite a while, doing some various scientific studies and taking lots and lots of really, really nice photos of the planet and the rings. Saturn is 74,900 miles in diameter and sits at a distance of 887 million miles from the sun. So that's another 400 million miles jump from Jupiter to Saturn. Uranus, again, gas cloud surrounding the planet. Not a lot of information that can be seen. Have to wait till space probes start exploring it in a bit more detail with different instruments. Uranus is 31,763 miles in diameter, and it sits at 1.8 billion miles from the Sun. So again, another big leap up in distance. Neptune, lovely blue planet. Again, it's one of those that needs exploring a bit more. This is from one of the space probes. I think they were called Pioneer, that went off out into the solar system a few years back now. 30,775 miles in diameter, and it sits at 2.8 billion miles from the Sun, so another billion miles further out than Uranus. So as you can see, the distances are beginning to get really big, and that is just purely within our solar system. And finally, I have included it, our dwarf planet, Pluto. This is an early image of it. It shows the lack of detail, purely due to the distance. It sits at 3 to 5 billion miles from the Sun and has a diameter of 1,450 miles. So very small compared to the previous planets. And this is a newer image from one of the space probes that have gone out there, showing a lot more detail and a lot more information. But unfortunately, classed now as a dwarf planet, so it's not included in the official list of planets in our solar system. Moving on, mnemonics for remembering the order of the planets. This can be a lot of fun. Found that the young people enjoy making up their own. Remembering that Pluto is now classed as a minor planet, but I still include it. There's a couple of examples for you. My very elderly mother just served us noodles. Or one that made me chuckle that I found on the internet is my vicious earthworm might just swallow us now. So, as I say, there's quite a few examples that you can find on the internet for that I found that the young people particularly enjoy making up their own. Moons of the solar system. As a follow-on, the Earth has 1 moon, Mars has 2 moons, Jupiter 79 and growing, Saturn 82, Uranus 27, Neptune 14 and Pluto 5. The moons around various planets are named after a theme. Again, this is a subject that would take up a whole talk on its own. So I won't go into a great deal of detail there. But again, solarsystem.nasa.gov can give you a lot more information. So I'll leave that there as an idea if you want to follow up on for one of your meetings. Constellations. These groups of stars that appear from our earthly point of view to form patterns in the sky. The groups of stars are also called an asterism, just in case you come across that term. There are 88 officially recognised constellations, 48 of which are known as original or ancients. This means they were documented and created by the Greeks, in particular Ptolemy, a 2nd century astronomer. They were probably documented also by the Babylonians and still earlier civilizations. The older names are mainly based around Greek mythology, hence the names of Cassiopeia, Orion and Perseus, etc. Please try to avoid the confusion between astronomy and astrology. Several constellations are visible during various times of the year, which are very easy to recognise and pick out from the starry background. It is sometimes easy to see the brightest stars when there is some pollution, light pollution. If the skies are very dark, it can get difficult to pick out the various stars from the background. A few years back now, I was away for a weekend, staying at a farmhouse out in the middle of Devon somewhere, and got back fairly late one evening, and it was a crystal clear sky, and the sky was just ablaze with thousands and thousands of stars. And it was really difficult just picking out some of the easy ones, like the plough, that type of thing, against the background of stars. It was amazing just how difficult it was. The easily visible ones are usually part of a larger grouping of stars, and it's these stars that are brighter against our light polluted skies, and that makes them easier to pick out. I'll start off with the Plough. It's part of a constellation called Ursa Major, the Big Great Bear. The Americans call it the Big Dipper. It forms the back and tail of the bear. This is another image showing the main stars that we call the Plough. The two bottom stars are actually quite interesting. They're also referred to as pointer stars or guide stars. And moving from left to right, the next brightest star in the sky that you'll come across is Polaris, or the Pole Star, or the North Star. That has been used for centuries as a navigation aid, as it appears to be stationary in the sky, with all the other stars and constellations revolving around it. This progression of the stars through the night sky means that the exact location of a constellation changes during the year. So it's a matter of looking up, identifying the constellation shapes. Just very briefly, there are various apps that can be obtained that will tell you what you're looking at in the night sky. You can just hold your mobile phone up at the sky, and it highlights the various stars and groupings for you to pick out. So that's the Plough. Moving on to Cassiopeia, or W Cassiopeia as it's sometimes called. The stars that we see are the 5 brightest ones, and in true scientific tradition, they're called Alpha, Beta, Gamma, Delta, and Epsilon Cassiopeia. Cassiopeia is located opposite the Plough, with the pole star in between. So if you just follow round through, and you'll eventually come to it. Just as a little extra, the Cassiopeia was a queen in Greek mythology. The legend is that Cassiopeia boasted that she was more beautiful than the sea nymphs, and this angered Poseidon, who is the sea god. So he sent a monster to ravage the kingdom. Cassiopeia's daughter Andromeda was tied to a rock to appease the monster. However, Perseus, flying along on his horse Pegasus, saw Andromeda and rescued her, and everybody lived happily ever after. The gods were happy and put everyone in the heavens as stars, except for Cassiopeia, who had upset the gods with her boasting. So she was placed in the sky to revolve around the North Star. Hence, this means about 6 months of the year, she is upside down. So moral is, don't upset the gods. Next constellation is one of my favourites, Orion the Hunter. This is a winter southern sky constellation. The Plough and Cassiopeia can be viewed all year round, whereas Orion disappears down below the horizon. Again, taken from another Greek mythological figure. Orion the Hunter is depicted as fighting Taurus the Bull, which is located to his right, and then to his left, slightly above and below, are his two hunting dogs, Canis Major and Canis Minor. Orion was the son of sea god Poseidon and a Cretan princess, Euryale. The shape of the constellation has been recorded back as far as mammoth ivory, as early as 32,000 to 38,000 years ago. So it's been well known as a constellation in the skies for many, many years. And it's also recorded in Chinese, Polynesian, Asian, Middle Eastern, and American history. So as we view it from the United Kingdom, the constellation of Orion is facing to the right with his shield held up. Very interesting if you do go to any foreign countries, particularly those south of the equator or near the equator, and the way the shape of the constellations changes, and trying to look at Orion upside down can be quite interesting. The three brightest stars in Orion across the middle in a horizontal line are called his belt. There's a group of stars below that called Orion's sword. Now you will be able to pick out a fuzzy area. This is another galaxy where there's well documented with some very stunning photos from the Hubble telescope of an area where stars are being born, that type of thing. The Horsehead Nebula is featured in there amongst it. Again, it would take a whole presentation just to cover all that, so that's something for you to look up if you want to at a later date. I've put a chart up of the various brightest stars within Orion. It gives you an idea of how far away they are from the Earth and how bright they are. You'll find that brightness is also called magnitude. It's a good way of introducing young people to the fact that the stars in a constellation aren't all on one plane, aren't all the same distance from the Earth. As you can see from the chart there, Betelgeuse is 624 light years away from the Earth, whereas Alnitak is 800 light years away from the Earth. So it's almost like a 3D puzzle being viewed flat on. so you're not getting an idea of the actual distances that things are away from us. Talking of the distances from Earth or the Sun, because we're talking about such vast distances, astronomers talk about distances in light years. What is a light year, I hear you asking? This can get quite technical sounding if you let it. It is okay to talk in approximate distances. Try not to get too bogged down with detail. So here we go. Light travels at a speed of 186,000 miles per second or 300 kilometers per second. So in one light year, this is about 6 trillion miles or 9 trillion kilometers. Just in case anybody asks, that would be a 6 with 12 zeros after it. So the Sun is our closest star and is about 93 million miles away, which means the sunlight we see has taken 8.3 minutes to reach us. Our next closest star is Proxima Centauri, which is 4.3 light years away, which means that the light we see from it started out on its galactic journey 4.3 years ago. This is a little chart I came across on the NASA Science Space Place website, which gives a very good example of the various distances away from us. And as you see from the chart, the distances do become so large that they can start to be difficult to understand and comprehend. This is why they've made the distances into light years to keep the numbers down just a little bit. Program ideas. Now, something I've done before is using some large size, thick paper card, mainly card, preferably black, and making pinholes in the position of the stars in constellation, and then shining a torch through from one side and asking the young people to guess the constellation. This is something that could be done as a basis with people, young people doing various constellations at the various bases. One little tip, if you are getting the young people to do the pinholes, I found, is to put a little dot of, say, a white crayon on the card in the positions that you want. This can help at least get something that does look a bit like the constellation you're after. You can, of course, ask them to make up their own constellations and give it a name and see what they come up with. The other thing I did with our cub pack many years ago now was we did a solar system journey, and I devised a travel passport for the cubs. And then using the bases, cubs visited the various planets where the leaders gave them facts about the planets and they talked about them. This was done over a couple of weeks, so it wasn't all crammed into one evening. But at the end of each evening, their passports were stamped, and I used, from memory, it was a moon or star-shaped stamps, the type that you can get from craft shops for card making, that type of thing. And then at the end of the journey, they all returned to Earth safely for a small welcome home party. As an added bonus, you can obtain freeze-dried astronaut food, and the most easily obtainable is ice cream, which went down really well with the cubs. You can make models of the planets or print off photographs and get the younger people to position themselves in the planetary order. Depending on the number of young people that you have, you could include some of the moons, and if space permits, I'd suggest possibly outdoors, and get the young people to circle around the sun, and with extra bit of fun is getting the moons to circle the appropriate planets. Another idea is to ask a local astronomical society if they can attend an evening with telescopes to allow the young people a chance to view the stars, the moon, etc. You'll find most societies will have an outreach section to assist you. I found 6 societies in Surrey. There might be more that I've missed, but the ones I found were Ewell, Farnham Night Sky. That tends to be, it's mainly astrophotography. So might be interesting, but probably more for the older age group. Guildford Astronomy Society, very strong group. Croydon Astronomy Society and Walton Astronomy Group. I came across a list of astronomy clubs at astronomyclubs.co.uk, and if you're near the county borders and it's easier for, say, Hampshire or Sussex astronomy groups to attend, then you'll find details of them on that website. And most societies will have a public viewing event of some sort, and just keep an eye on the local papers, local media, where they'll advertise the events. And again, members from the group, from the societies, come along with their telescopes, set them up. I've been involved with Guildford AS, and we use Newton's Corner quite a bit. And we just set the telescopes up, and members of the public come along and have a look and see whatever there is to view. And it's really magical when you get the, oh wow, gosh, look at that moments from some of the younger people who come along. Craters on the moon, they're very well documented, and it's something that's usually visible in our skies given the weather. Again, quick search on the internet will bring up the names of the larger, more distinctive craters. You could ask the young people to bring binoculars along and spend an evening observing the moon. Try counting the craters, try matching them up with the names of the craters that you've found. It's actually better not to view at full moon because there is such a reflection of the sunlight that it can obscure some of the details. It's far better to observe either side of the full moon when you've got oblique lighting, which will highlight the craters and their features. Some of the craters you can actually see like a little mound impact mound, right in the middle of them. Others, where there's been more than one impact, you've got a crater with another crater coming in from one side. Try and get the young people to work out which they think is the oldest. Things like that you can do. Another idea that may need a bit of research to put together. It's something that I thought of whilst I was putting this presentation together, is a top trumps type of game. Could be based on facts about the planets, galaxies, etc. The size of them, distance from the Earth or distance from the Sun, their magnitude, number of moons, anything like that that you can think of might be something that you could put together as in case of a wet weather program for camp for them to do, play with during camp. Meteor showers, good chance to go outside and view meteorites. Unfortunately, the viewing is best quite late in the evening. We're talking about 11, 12 o'clock. So it might be activity for camp where bedtimes do tend to slip a little bit. Sadly, we have just missed the Perseid showers that peaked earlier on in August. Next meteorite showers are the Draconids, which are visible 8th, 9th of October, and the Orionids, whose peak is expected to be the 21st of October. You'll find that days leading up to the peak, there will be some meteorites visible, but there's one particular day when we're passing through the dust debris at its maximum. There are 3 other meteorite showers or meteor showers due in November, December. Good place I found for details is a website called timeanddate.com. Meteor showers are named after the constellation they appear to originate from. So the Perseids appear to come from the constellation Perseus, which would be up in the northeast sky. Draconids appear to originate from the constellation Draco, the dragon. And when we pass through that, it will be in the roughly west-northwest sky. And then the Orionids appear to originate from just above the top left side of the constellation Orion in the southern skies. When you're looking at Orion, the very top left star appears to be a bit redder than the others, and the Orionids appear from just slightly above that. So actually, what are meteorite showers? They're very predictable and are caused by the Earth passing through the debris that's actually been left by a comet passing by. So the Orionids are from the debris from Comet Halley. Draconids are from the comet Giacobbe-Zinner, and the Perseids from Comet Swift-Tuttle. Again, NASA website has an awful lot of information. spaceplacenasa.gov is a thoroughly recommended site for other ideas. And just quickly going back to the solar system tour, this was the image that I had on the front of the passport. I was able to fit 3 of these going down an A4 sheet, which then gave me a reasonable size room to add pictures of the planets and the details on separate sheets and just staple and clip them together to form the passport. Well, I hope you've found this of interest and has given you some ideas as to how to present or make astronomy interesting for the younger people. And I hope you enjoy the rest of the virtual camp weekend. And thank you very much for putting up and listening to me.